Hi guys. This is going to be our last lesson with any new material. We only have, I don't know, maybe 5 days left. So we skipped an entire chapter on circles. We're not doing anything from chapter 11. I skipped the first part of chapter 10 and I really majorly glossed over the end of chapter 9. So, I don't know what to tell you. Those of you having to take the SAT, I don't know what that's going to look like. But for those of you going on to Algebra 2, the material that we are doing right now, you will get more of in Algebra 2. And this is really important stuff for those of you who are going on. What I showed you on Tuesday was the tangent ratio, okay? And so I'm not going to do sine and cosine. You may have noticed before, and maybe you did this in algebra, I don't know. You may have noticed you've got these sine, let's see. Yeah, what's happening here? You have a sine, cosine, and tangent button. And why do these look like this? Sine, cosine, right here. Sine, cosine, tangent. You have those three buttons on your calculator. And you actually could get around having to use all three of them by using the Pythagorean theorem first in some cases, but not all. But we're just going to focus on tangent because the tangent ratio uses the two legs of the right triangle. So in a lot of cases, if you think about how a lot of things work with slope, like the pitch of a roof, the steepness of, say, a road or just anything, it's steps. It's based on the idea of rise over run. So this triangle's upside down, but this angle right here creates a certain distance and rise over run. So I really feel like it's the most useful of all of them. Okay, so if you've ever heard the SOHCAHTOA, all that is a little mnemonic device to help you remember what these ratios are. But we're just going to do tangent. And we said tangent was opposite over adjacent. Okay, so this is what we did right here. We saw that if we were looking for the side opposite to the angle, and in a lot of the problems I gave you, this angle wasn't given. You had this one instead, which is no big deal. You just have to go ahead and subtract from 180 to get this other angle, okay? So you always want the angle across from the x. That's going to make your life a lot easier. Otherwise, the algebra of solving it is more challenging, okay? So I'm going to try to write on the screen, which never really works real well. But okay, so for this is what we did already. The tangent of 25. So the ratio for a 25-degree angle, okay, opposite to the 25 is x, and the adjacent leg to the 25 is 34. Okay, and so we know that the ratio of all the angles of 1 through 89 degrees are stored in your calculator. Okay, so all we have to do is take the tangent of 25 on here to find the ratio. Okay, and it is 0.4663. Okay, and this is why we use the angle that's across from the missing side, is because then all I have to do to solve this is multiply by 34 on both sides, because that's the opposite of dividing by 34, right? Okay, instead of dividing, we've got to undo this. So now I take that number, which is hopefully still in this calculator, and times it by 34. And then that'll tell me what that missing side is. Okay, 15.9. X equals 15.9. Okay, and then just think, does that make sense? If this is 15.9, does that make sense? Well, first of all, in the picture, it looks like it's shorter, although that doesn't necessarily mean anything. But 25 degrees is pretty small, so it makes sense that it would be smaller than the 34. Okay, so that makes sense. All right, so what we're actually going to look at is what do we do if we have the two sides, but we don't have the angle? What do we do? Okay, so in this case, I would take the tangent of x equals, and then the opposite to x is 2, and the adjacent is 10. 2/10, okay? So in this case, I've got, okay, the tangent of what equals 0.2. All right, so here's the problem. I have to make my calculator go backwards now. Rather than having the angle like I did up here, the x is now in the angle position, okay? So up here I did tangent of 25, and it gave me this ratio. Well, I have the ratio right here. It's 0.2. So I need to be able to get my calculator to go backwards. Here's the ratio. Now what angle did it come from? Okay. Well, the way we do that is, okay, I'm going to type in 0.2, okay, and then see how these say sine, cosine, and tangent? If I hit this inverse button, in some calculators it's a second button, okay, see how now it says tangent to the negative first? That makes the calculator go backwards. So if I click it now, it tells me it came from an 11-degree angle, 11.3 degrees to be exact. Okay, so I'm going to show you something. 11.3, okay, and just to prove it to you, I'm going to take the calculator and show you that if I had done 11.3 and hit tangent, it gives me, oh, nope, it doesn't, because I pushed the wrong button, didn't I? 11.3, it's in degrees. There it is, 0.2, just like I had, okay? So that's how you do that, all right? So the only difference is that we're going to have to make our calculator go backwards, okay? Now, so I'm looking for angle A and B both in this case, all right? It doesn't really matter which one you solve for first. Say you want to solve for A first, okay? Well, then I'd write down the tangent of A, okay? And then what's opposite to A? That would be 15 divided by 19. Okay, now I don't know what 15 divided by 19 is, so I'm going to have to use my calculator to get that. 15 divided by 19. Okay, so apparently it's 0.7895, okay? So 0.7895. It's not negative, I just didn't get my, okay, so the tangent. So now I need to make my calculator go backwards, right? It should still be there, 0.7895. So to make it go backwards, I hit this inverse button. Some calculators are second button. Okay, and it came from a 38.3 degree angle. So A equals, it went away on me. How much was it? 38. Let's just round it to 38 degrees so we don't have to have that decimal. 38 degrees, okay? All right, and so if angle A is 38 degrees, how do I get angle B? Well, you could set up the tangent of B equals 19 over 15, but wouldn't it just be a lot easier since there's 90 degrees in this triangle here, 90 minus this 38, oops, sorry, minus this 38 here, doesn't that just leave me with 52 degrees? Isn't that the easier way to get it? Yes, Mrs. Dare, it is. Good job. Okay, so I'm going to move on to number 2 here, okay? And it doesn't matter which angle I solve for first, either A or B. I'll just go ahead and do B first this time. So the tangent of angle B equals, what's opposite to B? 11 over 6, okay? So 11 over 6. So I'm going to take 11 divided by 6, and I've got 1.83 repeating. Okay? So now I have to make my calculator go backwards. So there it is. So backwards would be inverse tangent. So it's 61 degrees we're going to go with. Angle B equals 61. Okay, so how do I get angle A? Well, 90 degrees left for these two, right? So I've used up 61. 90 minus 61 would be 29 degrees. Just like that. Okay. I'm going to do one more for you here, bigger numbers. Okay, which one do you want to solve for? B, awesome. The tangent of B, okay, now I'm going to ask you what should go on top, 32 or 29? Remember, it's opposite over adjacent. Hopefully you're saying 32. Okay, so I'm going to take 32 divided by 29. There's the decimal, and I inverse tangent. 40, that would round to 48 degrees, right? Angle B is 48. Let me put it back up there so you can see. Because this is a 0.8, so that would 0.5 or higher I round up, so I'm rounding up. So 48 degrees, okay? And then angle A then is going to be 90 minus 48, since these two have to add up to 180, right? These two angles. So that'd be 42 degrees, just like that. Okay? I'm not going to do the last one because I'm hoping you probably got that. And just go ahead, and you don't have to draw the triangles on your paper. I have one person who is managing to print it out and write on there and then upload it. You don't have to do that. Just write your problems. Just write like what I did in blue here on your paper, number 3. Write it down and then turn it in. Okay? Thank you so much.